Imagine this. You open your eyes. You don't know who you are. You don't know where you are. You don't know why you're here. But you're on a spaceship, alone. And Earth is 12 light years away. This isn't a nightmare. This is the premise of one of the most scientifically accurate space films ever made, Project Hail Mary. But here's what the movie doesn't fully show you. The real science of surviving alone in space is far more brutal, far more fascinating, and far more terrifying than any Hollywood story. Today, we're going to ask one simple question. Could a single human being actually survive alone, cut off from Earth, in the void of space? The answer will change how you see the universe. Before we talk about surviving alone, let's talk about the universe's first weapon against you, space itself. The moment you step outside a spacecraft without protection, you have approximately 15 seconds of useful consciousness. Not because you explode, that's a Hollywood myth. The reality is quieter and somehow worse. At zero pressure, the moisture on your tongue and eyes begins to boil, not from heat, but from lack of pressure. Your lungs, if you hold your breath, will rupture. If you breathe out, you survive longer. Your blood doesn't boil immediately. Your skin and circulatory system are strong enough to contain it for a short time. But the nitrogen dissolved in your blood, that starts forming bubbles. The same condition deep sea divers call the bends, except faster, except everywhere. Within 15 seconds, unconscious. Within 90 seconds, death. This is day one, lesson one of surviving in space. The universe is not trying to kill you. It simply doesn't care whether you live or die. And that indifference is the most dangerous thing of all. But let's say you have a ship, a good one, with walls between you and the void. You're still not safe. On Earth, you have two things protecting you right now that you've probably never thanked: the atmosphere and the magnetic field. Together, they form an invisible shield, deflecting and absorbing the constant barrage of radiation pouring out of the sun and from deep cosmic sources across the galaxy. In space, that shield is gone. A NASA astronaut on the International Space Station, just 400 kilometers above you, receives approximately 10 times more radiation than a person on the ground every single day. Now take that astronaut and send them to Mars. The radiation doubles again. Send them between stars, like in Project Hail Mary, and you're talking about galactic cosmic rays. High-energy particles accelerated by supernova explosions, traveling at near light speed, punching straight through metal, straight through flesh, straight through DNA. These aren't just a cancer risk. A single high-energy cosmic ray event can cause what researchers call CNS effects: central nervous system damage, memory loss, personality changes, cognitive decline. Not in years, in weeks. NASA's current limit for astronaut career radiation exposure is 600 millisieverts for men, slightly less for women. A mission to Mars, just to get there, would expose an astronaut to around 300 millisieverts. An interstellar mission like Project Hail Mary? The numbers become almost meaningless. Without shielding technologies we don't yet have, a human would be dead from radiation alone within years. So our lone survivor needs a ship with serious shielding. Water works well, it's dense, it absorbs particles. Lid works. But weight is the enemy of space travel. This is the first paradox of deep space survival. Everything that keeps you alive makes it harder to go anywhere. Let's say the shielding problem is solved. Your body still has one more enemy, itself. The human body evolved over millions of years under one constant assumption: gravity would always exist. Every system in your body, your heart, your bones, your muscles, your fluid balance, your vision, was built around that assumption. Remove gravity and the body starts unbuilding itself. In microgravity, your muscles have nothing to resist. They atrophy, shrink, at a rate of roughly 1 to 2% per week. Without countermeasures, within months, an astronaut can lose the muscle mass of a decade of aging. The bones follow. Calcium leaches out of the skeleton. Bone density drops at approximately 1 to 2% per month in key load-bearing areas. Your hips, your spine, your legs. The bones become brittle, not slowly, but measurably, continuously. But here's the detail that fascinates and disturbs me most. Your eyes change shape. In microgravity, fluid in your body shifts upward, toward the head. This increases pressure inside the skull. That pressure pushes against the back of your eyeballs, flattening them slightly. The optic nerve swells. The result is a condition called VIP, Visual Impairment Intracranial Pressure Syndrome. Many astronauts return from long missions with permanently altered vision. Some describe seeing flashes and streaks of light, cosmic rays passing through their retinas like ghostly fingers. About 40% of ISS astronauts report some vision impairment after long missions. Now imagine not 6 months in space, not a year, a lifetime. A one-way interstellar mission, like the one in Project Hail Mary, could take years or decades. The human body without artificial gravity would be almost unrecognizable by the end. Our survivor needs a centrifuge, a spinning section of the ship to simulate gravity. It's doable, but it adds complexity, mass, points of failure. Every solution creates a new problem. Let's get brutally practical. A human being needs approximately 2,000 calories of food per day, 2 liters of water per day, 550 liters of oxygen per day. For a mission lasting even 2 years, the numbers become staggering. The ISS solves this partly through resupply missions, rockets from Earth bringing fresh supplies every few months, but our lone astronaut, 12 light years away, has no such option. Everything must be recycled. Everything. The ISS already does this to a remarkable degree. NASA's water recovery system recovers about 93% of all water on board, from sweat, urine, even exhaled breath. It's then filtered, chemically treated, and made drinkable again. Astronauts joke about it. Yesterday's coffee is tomorrow's coffee. But even 93% recovery means a slow, constant loss. Over years, over decades, that margin adds up. Food is harder. Plants can be grown in space. NASA has successfully grown lettuce, radishes, and other crops on the SS. But the caloric yield per unit of space and energy is still far below what a human needs long-term. A truly sustainable, lone astronaut mission would need a closed-loop agricultural system, essentially a miniature farm, managing pests, crop failure, soil chemistry, water distribution, all alone. One bad harvest, one fungal infection spreading through your crops, and suddenly your careful calculations collapse. Air is managed through chemical processes. CO2 is scrubbed from the cabin. Oxygen is generated through electrolysis of water. But these systems require power. They have components that wear out. They need maintenance. And maintenance requires tools. Tools require parts. Parts require manufacturing. Manufacturing requires raw materials. This is the brutal logic of deep space. Every resource is finite. Every system degrades. And there is no backup coming. We've talked about the body, but the human mind may be the greatest challenge of all. Solitary confinement studies, on Earth, in prisons, show that after just 15 days alone, otherwise healthy humans begin showing signs of psychological deterioration. Anxiety, hallucinations, depression, cognitive impairment. The longest solo space experience we have data on is limited. Astronauts on the ISS are isolated from Earth, but they're in constant contact. Video calls, messages, a crew of fellow humans around them. Our lone traveler has none of that. Even radio communication becomes impossible at interstellar distances. A signal traveling at the speed of light from Project Hail Mary's destination would take 12 years to reach Earth. A message sent, a reply received 24 years later. Effectively, silence. Researchers studying Antarctic isolation, submarine crews, and long-duration spaceflight simulation note consistent patterns. The brain, deprived of novelty, begins to manufacture it. Intrusive thoughts, false memories, the sensation of presences that aren't there. There's a documented phenomenon called third man syndrome. The feeling, reported by explorers, solo sailors, and climbers in extreme survival situations, of an unseen companion. A comforting hallucination. A presence that guides. It's your brain's desperate attempt to maintain social connection when social connection is impossible. In Project Hail Mary, Ryland Grace finds a real companion, an alien named Rocky. And that relationship, the film argues, is what makes survival not just possible, but meaningful. The science backs this up. Human connection, even imagined human connection, may be as essential to survival as food and water. A lone astronaut who keeps a journal, who talks aloud, who maintains rituals, who finds purpose, not just in survival, but in mission, has measurably better psychological outcomes in every isolation study ever conducted. The mind is not just a passenger on this journey. It is the most critical system on the ship. So, given everything we've discussed, could a human actually survive alone in deep space? The honest answer? Not yet, but the gap is closing. Artificial gravity through rotation. Solved engineering problem. We just haven't built it at scale. Radiation shielding using magnetic fields, mimicking Earth's magnetosphere, theoretically achievable. Closed-loop life support, AI companions for psychological health, suspended animation research, all actively being worked on right now. The only wall we haven't cracked is distance. The sheer time required to cross interstellar space remains the hardest problem of all. But 500 years ago, crossing an ocean felt just as impossible. We are not ready today, but we will be. The universe is not a place built for humans. It does not have our oxygen, our pressure, our temperature, our gravity. It does not have our need for connection, for purpose, for meaning. And yet, we keep looking up. We keep asking, what's out there? We keep building ships and writing stories and dreaming of the day when a single human being, alone, light years from home, looks out a window at an alien star and smiles because they solved it, because we solved it. Project Hail Mary is a story, but the science behind it, the radiation, the atrophy, the silence, the loneliness, the impossible logistics of keeping one human alive in the void, that's all real. And the fact that we're even asking these questions, building these technologies, running these experiments, that's the most human thing of all. If this video made you think about the universe differently, subscribe, because at Dark Cosmos HQ, we're just getting started.